Hello. In this video, we're going to go over the various sensors that are on the robot and then the various outputs, motors that we have on our outputs, and then how to configure using data from sensors to control output from our motors. So to start off, make sure you open the file, open the template file that's provided with this assignment. Again, the template file has all the motors and sensors set up on their proper ports, so they'll work directly with the VEX robot that we have in class. So we have 7 different sensors that we can access on our robot. We have our light sensor, which measures light intensity. We have the potentiometer, which measures an angle from 0 to 180 degrees. We have our line followers, which are infrared sensors that detect light gradient, so from white to black, how intense that light is. We have our wheel encoders that measure rotation continuously, which are used to track the distance that the wheels have traveled. We have our sonar sensor that uses sound waves to measure distance. We have a push button, and then we have a limit switch. So those comprise all the sensors, and then for our motors, we have our left and our right drive motors. We have our claw motor, and we have the arm motor, which raises the arm that the claw is on up and down in the vertical direction. So the main thing is that the two drive motors either have to act together to get forward or backwards motion, or work opposite or independently of each other to create rotation. Through that, we get our full X and Y um, ability to move in the 2D plane. The arm motor only acts in the vertical plane, and then the claw just grips, open and closes. And depending on how heavy the object is, you have to maintain the force of the motor to keep the gripper snugly gripped onto the object, because if you just stop that motor value, the gripper could tend to release and allow the object to slip out. So as for creating a connection between our sensors and our motors, you got to think about what sensors are going to help determine motion in each of our motors. So the main thing is moving the robot around. So what's going to be important for controlling robot motion? We have the ultrasound sensor, which is used to detect obstacles. So that's kind of a safety net to where we can stop before something is being run into. And then we have the line followers on the ground, which can follow some kind of high contrast line, so black tape on a light colored floor or white tape on a dark colored floor. And we have the wheel encoders, which measure the rotation of the wheel. So if we have a path in mind that we want to go, like a specific pre-planned path, we can use those wheel encoders to kind of count our steps and have it drive without having to use the sensor or a line follower. So you can use all 3 of these to control the motion of the robot. So I'm going to show you how to use each of those 3. So the first thing that you should have in the program is a way to stop the robot in case it's about to run into something. We don't want the robot to damage itself, so we need to be sure that it can stop should it either approach a wall or another object or person. So to do that, we're going to use our sonar. Again, it's the ultrasound. It measures distance of an object from the robot. So we have to determine some kind of threshold, so less than. So that means whenever the robot gets within a certain distance, so we can do within a foot. That gives us enough time for the robot to properly stop. Also, the arm of the robot sticks out further than than where the sensor is mounted on the robot. I'm sorry, the cat is jumping up on the computer. So we want to make sure there's enough of a cushion, and then you can experiment and fine-tune that value to your specific needs. So if the sensor value is less than 12 inches, we want the motor to stop. So you can either do stop all motors, which is probably the safest thing, or you can manually stop just the drive motor. So if you're carrying something, it won't stop the gripper motor or the arm motor and cause that to fall. Depending on your scenario, either will work. And if we don't have an obstacle, we can move on with the rest of our code and have it follow or move freely. So instead of just putting a motion command, I'm going to add in the rest of our code. So we're going to use the other two sensors on top of this. So we're going to layer all three different sensors together. So what we're going to do is we can do another if-else statement. If our left encoder, since we can't check two values at once, we can only have to choose one or the other. So we're going to assume both of our wheels are operating at the same speed. This isn't going to be ideal because usually the voltages will vary slightly. The motors will, one will be slightly more efficient than the other. But while the left encoder is less than 10,000, we're going to set multiple motors, and we're going to have left motor and right motor move at half speed. After that speed, we're going to stop all motors again, and then we're going to move on to the next portion where we have it follow a line. So to do that, you have to program the line follower. Stop it. Psst. So we have three different sensors on the bottom of the robot. So the way that works is we have a left, a right, and a center. If the center one senses dark, that means we're on the line and we can continue moving straight. Now, should one of the other two sense the line, but the center one isn't sensing the line, then we need to counteract that motion and move in the opposite direction. So to do this, we're going to take a couple more if statements. So we're going to have three different cases. Our first one is if our center line is greater than 150, and that's roughly a safe value to judge between a light surface and a dark surface, we're going to have the motors go straight. So we can again copy and paste our half-speed motors. Now we can go to our right encoder. If our, sorry, not our encoder, our right line. If our right line sensor is greater than 150, that means our middle sensor has fallen off the line, but our right sensor is still on the line, so that means it's veering left. So that means we need to steer it right to get back on track. So again, we can set multiple motors. Actually, for this, we're going to need to set the motor separately since we want to create a speed differential. So we have left, we have right motor. So for our robot to steer right, that means our left wheel needs to travel faster than our right wheel. So what we can do is we can take the speed of our right motor down, and then we can up the speed or leave that one still. So what this does is the two motors are now going to be spinning at different speeds, causing the robot to turn from left to right, from the greater speed to the smaller speed. So think of when you're trying to figure out, am I turning left to right? You're turning from left to right, going from the higher number to the lower number. So for this final if statement, which we don't even need, because the third case is that it's off the line, and if it's not on the right one, that means it has to be on the other one. So we're going to just take our set motor commands again. Left motor, right motor. And we're just going to reverse this. So this top one will become 30. So now we're going to steer left. So this should allow our robot to drive around using all three different sensors. It's going to always stop if our sensor value is less than 12. It's going to check for that left encoder value. That keeps counting, so that's only going to happen for the first 10,000 ticks, which I forget roughly the distance, but it counts probably, I think it's roughly a couple hundred per inch. And the last thing we would need to add to make this actually work is we just put it all inside a repeat forever loop. So it goes through all these if statements. At the end, it comes back around and it keeps checking. So it just keeps checking, and that way it always is checking its sonar, it's always checking the encoder, and it's always checking the line sensors. So that's the motion there. What we can also do is if we want to have the arm or gripper move. So inside the gripper, we have our limit switch, which we call arm limit here. So if the arm limit is equal to 1, that means it was pressed. So if it was pressed, we want to then close our gripper. So we set our motor, we go to claw motor, and we set it to 50. So that's going to open up the gripper. If it's not pressed, we want to make sure our gripper is open. Or really what we can do is we can just stop it because we just want it to stay stationary. So that's a way to where you can have the gripper open. Your robot can approach whatever object it is. When it trips the limit switch, we know that that object is within the grasp of the gripper and it can automatically close. The last thing we can do is we have our potentiometer. So what we can do there is another if-else statement. So the potentiometer measures the angle of our arm. So what we can do here is we can do about 2000, which is about 90 degrees. If our arm is at an angle of less than 2000 degrees, or 2000 raw data, so roughly 9 degrees, we can come down here, we set our motor again. This time we go to our motor and we have it move up at positive 50. If it's above it, we can have it stop the motor. And so what this will do is if the arm is less than 90 degrees, it's going to move it up. Once it hits 90 degrees, it'll stop. And if the arm comes down due to gravity, it'll then turn it back on. So it'll basically oscillate. It'll bounce up and down around 90 degrees. So those are the main sensors that go into controlling each of the motors. The sensors that we didn't use in here, we didn't use the button, which most easily can be used as an on-off switch for the robot in the program. So you can use that as a while loop. So actually we can go ahead and add it in here. So we can have it while button is equal to 0. We're just going to stop. Actually, get rid of the while. We're going to just, we don't want to repeat. Sorry, we want wait until. Wait until the button is equal to 1. And then we want to actually move that out because we only want to check for that button at the very beginning of the program. So after it completes one lap of the program, we don't want to recheck the button or else it would turn off. So at the very beginning, it waits for your button to be pressed. Once it presses, it'll start the code and then ignore the button for the rest of the code. And the only other sensor we haven't used is the light sensor, but you can use the light sensor to control the speed of the robot. So you can take that, that's where you could use a variable. You take the intensity of the light, you multiply it by some factor, and that becomes your speed value. So you guys can kind of get creative with how you want to use the rest of these, but this is just kind of the most straightforward way to use the various sensors to cause motion in each of the 4 motors on the robot. So I'm going to slowly scroll through everything just so you guys can get one final look at it all. And hopefully after this video you have a little bit better understanding. I know this is kind of a longer program that looks a little intense. That's why it is very important to map out what you plan on having your robot do in a flowchart, because once you have it mapped out in the flowchart, turning it into the code becomes way simpler. And then obviously using comments to describe what everything is doing also then makes it easier for you guys to follow along with when you're looking at it, and kind of breaks it up into the sections that like for each category and what's working with what motor.